So, oh, let's close the blinds. Lawrence, would you mind closing your blind there? Have to get back into the routine here. Need one of those automated blinds. Using a remote, right? So, the biggest thing that I want you to take note of, we're going to spend first on time on probability, and then we're going to move over to odds. But I want you to know right away that probability, arrow out like that, right? Likelihood of something, right? Likelihood of an event. That's basically what probability is. It tells you what is the likelihood of something happening. And there are three main ways we can say that. We go usually probability of the event in brackets like that. So whatever the event is, like let's say rolling an odd number, whatever, would be number of outcomes that you're favoring, right? Number of outcomes over total outcomes. Let me zoom into that. So if you're squinting, maybe we will make it a little bit easier, right? So it's the likelihood of an event happening. So probability of that event. So let's say probability of rain, right? We could state it. It can always be stated as a fraction. In fact, probability is probably the most common way of being it's being stated is as a fraction, right? So just up top here, you can say that, you can state it as a percentage. So we're going to go arrow up from probability, percentage, fraction, and decimal. Okay. So probability can be stated as a fraction, percentage, or decimal. So I'm going to circle probability here and kind of just make sure that those two arrows coming off of it, it pertains to probability. Okay. Next, let's talk about odds. Circle odds like that. I know that some of you might have had teachers in elementary or junior highs saying that, hey, you can state odds as a fraction as well. If that's the case, I want you to not go there. Okay, don't state it as a fraction. Instead, it would be stated like this. Favorable, right? And against. That's how I want you to state. Sorry, you can't see that. Sorry, my bad. There. Favorable and against. I always want you to state it as a ratio. Okay? It's a ratio with the dots in between. So odds, you always have the two dots in between. Okay? Make sure you understand that to get this right. And notice that there's no total. No total ever. Okay? So you should not have the total number of outcomes appear on that ratio that you just stated there. And we'll talk about that more later on. So first we're going to stick with probability, then we're going to introduce odds, and then we're going to go in between odds and probability because you can actually go back and forth between the two. Okay? But not today. Actually, let me just, the workbook will have something about this later on, yeah. Okay, so let's move on this page here. We're going to start with simplifying fractions to start us off. And you're probably like dreading that, but you don't have to. Okay. Before we move into experimental probability, I want you to flip over to that second page. There's a blank section there. We're going to make a distinction between the two types of probability that we're going to be talking about. So on page 144, you have that half a page that's blank, and that's there for a reason. So there's two types of probability. So let's start with probability at the top, right? So probability, circle that. And that branches off into theoretical and what we call experimental. Okay, I will circle those two as well. This is very important for you to understand, okay, that when we're talking probability, there are actually two different types of probability. Just focus one more time there. One more. Huh. There you go. So theoretical probability. So theoretical stands for what should happen. Okay, and that is quite often when you're playing games like card games, dice games, you name it, like a spinner. If you have a spinner, we base it on like just simply what we observe and what we expect should be happening. And experimental is what actually happened. Okay. So for example, when we're looking at elections, when they do the polls to kind of predict what's going to happen, it's based on actual polls, right? Asking people, who are you going to vote for? Who are you going to vote for? You can't go, there's three candidates, therefore the first one is 1 in 3 chance of winning. It's not true because, right, people prefer one candidate over the other. So there's that. And this is where what I want you, when I will say this, when you have a small sample size, right? If you have a small sample size, then the theoretical will not be equal to the experimental. A large sample size and how do you get a larger sample size, right? Increase number of trials. And I want to say something here before I move on. We're going to go back to experimental, and under the experimental section, we're going to also add based on actual trials, right? Polls, etc. So it's the experimental is based on actually either rolling dice or actually pulling cards from a deck or actually doing something. Okay, and so that's why we're saying it's based on what actually happened. It's based on trials, polls, so forth. So a large sample size. So if you increase the number of trials, then the theoretical probability will not be exactly the same, but very close. So you do the wiggly, you do like the two waves like that. The theoretical is close to the experimental. This is very important to know. Right? So for example, rolling a 1. What's the chances of rolling a 1 with a standard die? 1 out of 6, right? Do you think that if you roll a die 5 times, it's going to actually end up being 1 out of 6 at the beginning? At the very beginning, if you only roll 5 times, you're not going to observe that pattern. But if you roll 100 times or 200 times, then you're going to start seeing that 1 out of 6 times you get the 1, right? So that's what I mean by increasing the sample size or getting a larger sample size, then you have a more accurate representation. Another one, if I ask for the toppings, the pizza toppings that are most popular, if I just ask this room, right, can I say, like, if 5 out of you like pepperoni, can I say that 5 out of 24 in general like pepperoni? Would that be accurate to say? Maybe it is true for this room, but if you look at Winnipeg, you'd have to ask more people, right? You'd probably have to ask, what, 1,000, 2,000 people, and then you probably have a pretty good idea of, in general, what is like the most, right? So you increase your sample size. That's what we talk. Sample size might seem like a fancy word. It's basically just increase the number of people you ask, the number of rolls you make, and so forth. That's what we refer to as sample size, okay? If you remember that, you're in business, okay? I also want you to know this here. Probability in favor of something happening and the probability against something happening, an event, will always be equal to 1 or 100%, or let's say it's 5 out of 5, 7 out of 7, 105 out of 105. Like, it'll always be 100%, right? So if you think about if it's a probability of rain, if probability of rain is, let's say, 60% for tomorrow, okay? I don't even have to tell you this, but what would be the probability of it not raining? What would it be? 40. Yeah, 40%. I didn't tell you that. You just knew it, right? As soon as I said probability of that happening is 60%, you knew it must be 40 of it not happening. Okay? So combined, you get 100%, which is also 1. Like 1 is the same thing, right? Probability of passing the course. Let's say probability to pass your first driver's test, right? Your first, actually, let's say it's 0.35. What's the probability of not passing? And you're like, wait a minute, it's a decimal. What is that? I don't. 0.65, right? Just go 1 minus that. Just like you went 100 minus that to get 40%, you just go 0.65. So when you know one, you will actually know the other. It's complement, right? So in probability, we often talk about rain and not raining, or passing, not passing. Probability of rolling at 1 versus probability of not rolling at 1. There's always the not of it, right? So those add up to 100%. If you understand this concept, you will know exactly what to do when I give you one of them, right? So keep that in mind. These two add up to 1, which can also be said to be 100%, right? So 1 and 100% is the same thing, okay? You know what? I'm gonna grab my highlighter here and just make sure this sticks out. I didn't have room to do a fraction type of question, but I think you get it. And this one too here. So there will be a number of instances where I ask you, hey, how come what was predicted is not matched with the actual outcome? You will have to look at the number of trials or the sample size. Okay, that's it. I'm going back again, back to the front. And from time to time, not always, I will be specific on a test or whatever when I want you to do this, right? But simplifying fractions, I want you to write this down. What does simplifying fractions simplify means? To write in lowest terms. Write that down. So if you ever see simplified fractions, you want to write in lowest terms. So here's how you do it. I will give you 3 divisibility rules. There's way more, but I want you to have these down. Divisibility rules. There you go. Divisibility rules. Some of you will remember. So I want you to know that if last digit, is even, underline that, that means that it ends in 0, 2, 4, 6, 8. Let me zoom into that. Okay. If the last digit is even, we divide by 2. Okay. So I'm going to highlight that. Even, divide by 2. If sum of digits is divisible by 3, then we divide by 3. If sum is divisible by 3, we divide by 3. And right now, just write it down. If you're like, what? Just write it down and I'll walk you through it. If last digit is 0 or 5, divide by 5. All right. So these are the ones that are going to help you the most. And this is how you simplify a fraction. And I know some of you are like, I know this, Mr. Erickson, don't reteach something that I already know, right? Well, I can't help it, right? So for example, both of these numbers right now do not end in a 0 or a 5. They're not even. So this is what you do. 3 and 9 is what? 12, right? Can you divide 12 by 3? Yes, you can, right? That means that 39 can be divided by 3. So let's park that thought for now. Let's add up the bottom here. 1 and 1, that's 2 plus 7. That gives you 9, right? Can you divide 9 by 3? And the answer is yes. So what you need to do here is you need to divide. This only works if you divide both of them by the same number. So we're going to divide 39 by 3. Where's my calculator? I should know this, right? But it's Monday after spring break. 39 divided by 3, 13. So I write 13 down. And then I go 117 divided by 3. That's 39. And you might think that's it, right? And so you're back. What can I do here? 1 and 3 is what? 4. Can you divide 13 by 4 by, sorry, can you divide 4 by 3? You can't. So you're done. You can't do the 3 thing anymore. You can't do the 2. And you for sure cannot do divided by 5. So then you need to try bigger numbers. Do you see that you can divide both of them by 13? So we divide this by 13 and we divide this by 13, and I will put the answer underneath here. 13 divided by 13 is 1. 39 divided by 13 is 3. And then you're done. That is a simplified fraction. Now, I will tell you this. Simplifying fraction is not going to like make you pass this unit. That's like if you struggle with that, you're actually going to be fine most of the time. Okay? Let's do the next one here. Watch how I'm going to do this. This is only one way of doing it. Okay? So pay attention. I see that they're both even, so I will divide by 2 right away. Even if you think, oh, I can divide them both by 4, just keep dividing by 2. So watch this. 32 divided by 2 is 16, right? That's half. So you go 16. 48 divided by 2 is 24. I'm not done yet. So I keep doing that. Divide by 2, divide by 2. 16 divided by 2 is 8. 24 divided by 2 is 12. And you're like, this is a lot of work, Mr. Erickson. Go ahead and do whatever you need to do to get there. Some of you might do it in 1 or 2 steps. Some of you might need more steps. 8 divided by 2 is 4. 12 divided by 2 is 6. I will keep going because they're both even. Right? 4 divided by 2 is 2. 6 divided by 2 is 3. And that's when I stop. I can't go any further. Okay? Yeah. Yes. Yeah. So some of you might have divided both of them by 4 right away. So that'll make it less, right? Some of you might divide it by, what did you divide by, 6? Or whatever you can do to get there faster, that's fine. Absolutely. Watch this. Let's say you're completely out, you don't know how to figure this out. This is what I suggest some students do. Take those two numbers and divide them. And sometimes you can tell right away, oh, that's probably going to be a 2/3, right? Or you get 0.25 when you divide them. It's like, oh, 25, right? Like it's 1 out of 4. That's the most simplified version of that. So that's another way of doing it. As long as you know how, you'll be fine. So let's try. I want you to try next page. Simplify maybe at least 2 of these on the back side here. Let's say we do A and D for sure, and then these 2 we'll see if we have time, right? I don't want to spend too much time on this. So A and D right now, try to simplify both of those. And then if you are done, go ahead and try B and C as well. But for now, just A and D, okay? And then let's see how you did here, because I want to actually go on to something else. So you have the calculator, right? Your best friend, your weapon. So some of you saw that you can divide both of them by 9 right away. If you see that, great. But let's say you didn't see that. You cannot divide 45 by 2. Keep this in mind. You have to divide both of them by the same number. You can't say, oh, the top by 3, the bottom by 4. It doesn't work like that, okay? So I see that this adds up to 9. This adds up to 9. I can divide both of them by 3. And I know I'm going the long way, so bear with me. So this would be 15. And the bottom is 24. You should be able to see that you can divide both of them by 3. And so that is 5 over 8, right? So if you got 5 over 8, you get the marks for reducing, right? So then I'm going to go over here to 54 over 81. I hope that you saw that you could divide both of them by 9. So that's 6 over 9, right? And then you keep going. I can divide both of them by 3, right? So that gives me 2 over 3, right? And if you didn't know that, right, 54 divided by 81, it is 2/3, right? So there we go. The other ones, let's do this one here. I notice that they're both even, so I'm going to divide both of them by 2 right away. Right? So 168 divided by 2 is 84. And then 294 divided by 2 is 147. Dividing by 2 doesn't work anymore, right? You're stuck. 5 for sure doesn't work. So I'm going to try the 3 rule. 8 and 4 is 12. 1 and 4 is 5 plus 7 is 12, right? So you can divide both of them by 3. You've checked to see and make sure both of them are divisible by 3. You get 28 and you get 49. Okay. And now you're like, okay, they're not both even, so I can't do 2. But you should have recognized perhaps that you can divide both of them by 7. Right? So that gives you 4 and 7 like that. Okay. So 4 over 7 is the answer there. Let's have fun with this one here. I would divide both of them by 5 right away. So that gets you 135 and 315. Oh, they're still both 5 at the end. So I will keep dividing by 5. I would appreciate you showing me this step. Like, what are you dividing by? Just in case you make a mistake, right? Then you get 27 over 63. Can't do the 5s anymore, but you should be able to recognize, I'm pretty sure I can get the 3 in there, right? Because this adds up to 9. This adds up to 9. So I'm going to divide both of them by 3, which gives me 9 over 21, right? I can still divide them both by 3. That gives me 3 over 7. So if you got 3 out of 7, yeah. No, if it's correct, you're good. Yeah, you don't have to show me what you divided by. It's just in case you make a mistake. Good. So this is just every once in a while, if you see this, if you see simplify, you need to simplify, okay? If you want full marks. But that's always at the end. That's not the first thing that I'm going to ask you for. First, I'm going to say, hey, what's the probability of it raining tomorrow, right? Based on this, right? And so forth. So let's go to the next page there. And this is where I need you to be able to go from one column to the other. And we are going to fill in this column here. Okay? What do I want to say here? It's best it's best when you go from a fraction to go from there to decimal and then go back to the fraction to get your percentage. Don't go from one to the other to the other. Go back to the original. Okay, so this is what I mean by that. Decimal, you just go 1 divided by 5, right? Decimal, you just go top divided by bottom, and you get 0.2. No surprises there. Okay? Then I want you to go back to this one and say 1 divided by 5, right? And then you multiply by 100. Just trust me. Down the road, you're going to get lots of decimals, right? So you want to go back to the original to get that, okay? So I would say 1 divided by 5 times 100 is what you did to get that. And here you just went 1 divided by 5 to get that, okay? And make sure you give up to 2 decimals there. Next, you got 0.70. We're going to go this way. We're going to go times 100. 0.70 times 100 gives you exactly 70%. And this is where it gets a little, I don't know if you remember this part. Decimal to fraction, yikes, right? Go over here. So we go from the original and then we go to the next. This is how you do this. How many decimal places? Actually, you write down the whole thing as is, 70 over how many decimal places? 2, right? Watch this. You go 1 and then you fill in the number of zeros that correspond with the number of decimals. Okay? And obviously you can cancel the trailing zeros. So this would just be 7 over 10. Right? Yeah. And this one I won't ask you to simplify. Like on a chart like this, it just gets too complicated. As long as the fraction is correct, bingo, you get the mark. Okay? Let's do this one here. 12.5%. Let's go to here first. We're going to what? Divide by 100. So take that 12.5 and divide it by 100. You get 0.125. I encourage you to write down the whole thing. Okay? Just write down the whole thing. And then I go from there to fraction. Okay? So this is what I'm going to do. Watch. Just read the decimals. 125 over the number of decimals. You count them. 1, 2, 3. So that means you will have a 1 followed by 3 zeros. And we're not going to simplify. Okay? Don't simplify on a chart like this. I won't take any marks off because that's not the point. The point is just can you go from one to the other. We're going to extend a little bit here. Oh boy, I'm going to cross over my 100. There you go. It's okay. We can figure that out, right? And I'm gonna leave that cell empty here, this one that we used, but then just add 4. If you have a ruler, great. If you don't, just we're not gonna fill the whole page. Don't worry about that. Just add like 4 rows there, and I'm gonna fill in a couple. Write these down. 3 over 7. 75.25%. 0.46 and 4 over 11. I'm going to highlight those so you know if you go through your notes, these were given right at the beginning and I asked you to fill in the rest. So here are little nuances. For this unit, okay, write this down on the side note here. Note, use up to 4 decimal places. Okay, so for decimals in this unit, I will quite often use up to 4. 4 decimal places. So this is unique to this unit because when we make predictions, we want to have more than just 2. So grab your calculator. And so basically the first thing you do is 3 divided by 7. And we watch this. Everybody on the screen for a bit. You count 1, 2, 3, 4, right? This is where you would cut it right after the 4th. So what would the 7 do to that number here? The 7 would bump that up to a 6. So it's 0.4286. Not all decimals give you lots of decimals, right? But this one does. So you go like that. Okay. Then leave this on your screen. And so you go 3 divided by 7 times 100. And that's when you write down your decimal, your percentage. So it's 42.86%. Okay. So your percentage, you do round to 2 decimals, but the decimal answer, I use up to 4. So let's make that clear in our notes here. Stating decimals. Right? Stating decimal, we'll use up to 4 decimals there if you want to state it like that. Okay. Now, 75.25, you take that, you divide it by 100, so you get 0.7525. And now it's a trickier part here. Let me zoom in. Just copy down the decimal as is, 7525 over 1, and then just count the number of, right? There's 4 digits, 4 zeros. Okay, and you have the correct fraction. Yeah. Oh, yeah. Thank you. I apologize for that. 75.25 over, my bad. There we go. And then you have your decimal. You can go over to the right, just multiply it by 100. You get 46%. You go over to the left here, it's 46 out of 1 followed by 2 zeros. Right? I'm sure that's not a surprise. And then the fraction again, 4 divided by 11, that's 0.3636. And then you multiply that by 100 and write down your percentage there. So coming from a fraction, be aware of the 4 decimals coming from the fraction. If I give you that decimal, there's no way to get 4 here, right? It is what it is. So that's that. Okay. Let's go to the next page here and let you do one of those real quick. So I'm going to leave this up, but go to the next page and fill in that chart that's there. And then I'll talk a little bit more. I need to do a little bit more after this, okay? So try to get through this. Okay, so just follow along. This gives you 89 over 100, right? If I go this way, or 89%. If I go the other way, this would be 0.67, which in turn would be 67 out of 100. What I don't want is decimals, okay? So if you ever sometimes students they grab the number at the end here and they put like a decimal on top. I don't want that, right? So you got to make sure you only have like whole numbers everywhere. 2 out of 37, it would give you 0.0541. Watch that, right? It's a small number, right? So you have that 0 there. Don't drop it. Multiply that by 100, you get 5.41%. Okay. 0.03, I will go this way and I say 3 over, you count the decimals, right? So that's 100. 3 out of 100 is your percentage, that's your fraction, and this would be 3% if you multiply that by 100 to get that. 0.45 going this way, which would give you 45 out of 100. And yes, you can reduce that one, but we're just going to leave it, right? 11 divided by 12 is 0.9167, which turns out to be 91.67% like that. So you should be able to, like on an AC tomorrow, fill in a chart like this with everything that goes with it. Okay. Now, if you have a highlighter, I know I'm gonna kind of like download a lot of information for you guys, and this is basically where we start. This is basically what this unit should be starting with. I just warmed you up to reducing and all that fun stuff. Okay, watch this. Working with experimental probability. Okay, experimental. I will write that down. And remember, when we're talking experimental, it's based on trials, right? Trials or experiments. It's what actually happened. It's based on what actually happened, okay? So you may have heard an expression, 8 out of 10 vets recommend a certain brand of pet food, 70% chance of rain today, all of that. These expressions are probability. And watch this. Probability is the prediction of how likely it is that a particular event will happen. Okay? A probability can be expressed as a fraction, decimal, percentage, and words. Yes, words as well. Okay? The formula for calculating the probability of an event, we call it A, is this. Right? This is your probability of its number of occurrences over total number of possible outcomes. And watch this. This is not in your notes, so you need to write this down. A probability of an event not happening. Watch this. A little line on top of the thing means it's not happening. Okay? Just say number of events where A is not happening. Sorry, it says not occurring. Okay? Number of events A not occurring over total outcomes. And watch this, the total in probability is key. If there's the total number of events, that means that you're definitely talking probability. It says probability is expressed in lowest terms only if required, right? Keep your highlighter handy. Experimental probability is calculated based on measuring occurrences of A in a sample data or running trial to find out how many outcomes, how many times A occurs. Okay. Using the results of the sample, right, you can make predictions about the likelihood of future occurrences. And I want to add something here. Write it down nice and big down here. to make a prediction, you take the probability of the event times sample. This should be boxed in. This is not on your formula sheet. This is just courtesy of Mr. Dirksen, right? So to make a prediction, like if they're asking you, hey, how many people would you expect to vote for this candidate? How many people would you expect to have a certain blood type? How many people, right? You use this formula, the probability of that thing happening times the sample size, which is a big number, usually thousands or a couple hundred, right? So you will make that just now on the next page, okay? So follow along on the back on 147 here, okay? So let's do a word problem here. Georgina bought a bag of bulk candies, right? She counted them and found that 15 were red, right? So 15 red ones, 10 green, 12 purple, and 13 were orange, okay? Calculate the probability of a randomly chosen candy from the bag being red. Express the probability as a fraction, decimal, percentage, and in words. We're going to do that. Can I just say something? Don't let that throw you off. You have to randomly select, or else you can't really put a probability to it. If you're looking inside the bag and you grab, like my kids always do, Skittles, right? They always grab the red one or whatever their favorite is. That's not randomly. It's basically you just gotta look away and just grab one. That's when probability works. Okay. So here we go. Watch how I write these things down. Probability of grabbing a red candy would be, how many reds are there? We have 15. And what goes in the denominator? Our total, right? So just for this demonstration, right? Just for this example, I'm going to go 15 plus 10 plus 12 plus 13. This is what we call the total, right? You need to have the total number of candies. Sometimes it's given. Sometimes they just say, hey, this bag of candy has 200 candies, right? They'll tell you that, but in this case it didn't. So we write it down like this, 15 out of, that happens to be 50 if you add this all up. Let's say we want to simplify it. This should be easy peasy, right? Divide both by 5, you get 3 out of 10. That would be, you would get the marks. If I didn't ask you to simplify, 15 out of 50 gets you the mark. But this is simplified. We can write this as a decimal, put a comma in between, okay? So comma, decimal, comma, 30%, right? So, oh, and 3 out of 10. This would be in words. So it's actually pretty easy to do. Just add the out of in there, and then you're good to go, okay? Next, B. What's the probability of a randomly chosen candy being green or purple? What's going on there, green or purple? In math, in probability, in math, or you have to add, okay? Green or purple. So probability of green or purple, we have 10 green and we have 12 purple, and we know that this is still out of 50. We don't need to do that again. That gives us 22 out of 50. We can divide both of them by 2, which is 11 out of 25. You're done. And watch what I'm going to do now. If you want 100% on this question, you would go 11 divided by 25. Oh, actually, this one isn't too bad at all. 0.44. You multiply whatever's on your screen by 100 and you round that to 2 decimals. In this case, no need to do that. And then you can go 11 out of 25. If I ask you for words, that's what you would do. It's actually pretty easy to do. Okay. C, watch this. This is where the prediction comes in. Let's read the question together. If the distribution of colors in 1,000 candies, right, in a bag of 1,000 candies, let's do this. This is your sample, right? This is what I would call the larger sample, right? How many would Georgina expect to be red? You're making a prediction. Making a prediction. Okay? So I use this. Prediction is going to be, what's the probability of a red? I already determined that. It's 3 out of 10. Watch carefully. Or 15 out of 50. Either one. I'm going to use 15 out of 50 just in case I made a mistake in reducing a fraction. Because if you reduce a fraction incorrectly, it's going to carry with you. And then times 1,000 candies. And you get this. This is how you calculate that. 15 divided by 50 equals times 1,000, 30. I will tell you this. This number is often a decimal. Your answer that you're getting here could have been 29.97 candies. Write that down, but then always round it to a whole number, okay? Because we're talking candies, often will be number of people, number of votes, stuff like that. Round it to a whole number, okay? Is this right? Because 0.3 times 1,000 is probably 300, right? Yeah, sorry. I just keep talking and forget to write down that extra zero. My bad. It's 300 candies, right? 30%, 300 candies. Okay. Watch this. I'm going to add. That's why I left a bunch of blank spaces there. D. How many candies are expected to be orange in a bag of 3,500 candies? So if this distribution continues, how many would you expect to be orange? Okay, so prediction. What's my probability of getting an orange candy? You look up, you're like, I don't know. Let's go up here. In the small bag we had, 13 out of the 50 were orange. So we base it on our smaller bag. This is the probability of orange. Probability of orange. Okay, that's what that is. And then you multiply that by the number of the larger sample that you have here, which is the 3,500 bag, right? So that would give us, watch this, I hope this is going to be a decimal. So 13 divided by 50 times 3,500, and that is exactly 910. So no need to round to a whole number. Candies expected to be orange. Okay. Oh, and I'm just out of time. We're gonna leave it there. Thank you guys. I know I did a lot today, but tomorrow we'll do more of this kind of stuff. And just be ready for the AC to have one of those tables and simplifying fractions. Just that. Okay.